We continue Unit 10, Graphing Square Root Functions, with Flap 3 in our foldable. If two relations are inverses, they are reflections across the line y equals x. To find the inverse in a table, you just switch the x and y coordinates. To find the inverse of an equation, you switch the x and y and solve for y. Remember, to be a function, a graph must pass the vertical line test. To determine if the inverse will be a function, the original graph must pass the horizontal line test. New word there, horizontal line test. In example 1, it says, graph the relation and connect points, then graph the inverse. So the first thing I need to do is graph the relation f of x and connect the points. Now I'll make the table for f inverse of x by switching the x and y values. Now let's graph these switched values. Notice that the black is the original, the green is the inverse, and they reflect across y equals x. They are mirror images on either side of the red dotted line y equals x. Now we need to determine if it's a function. So we draw a horizontal line through the original. At this point it is a function because it only crosses one time. Again, we draw a line through the original function, a horizontal line. These horizontal lines only touch the original graph one time. Therefore, it passes the horizontal line test. It is a function. Let's look at example 2. Graph the inverse and tell if it is a function. The first thing we need to do is plot the original points of our function. Then we plot the inverse points to our function. Now let's determine if the inverse is a function by doing the horizontal line test. So far it's a function, but when I draw my second line, it touches in these two spots. Because the original fails the horizontal line test, its inverse will not be a function. Look at example 3. Write the equation of the inverse. First thing we need to do is rewrite the equation. Y equals 3x minus 1. Now we could switch the x and y values. X equals 3y minus 1. Solve for y. If we add 1 to both sides, I have x plus 1 equals 3y. Then we divide by 3. That leaves me with x plus 1 divided by 3 equals y. We're done. We just need to rewrite this equation. F inverse of x equals x plus 1 divided by 3. Notice we write the inverse with a little -1. That's how we denote it. Example 4. Write the equation of the inverse. F of x equals 1/3 x plus 7. First thing we need to do is rewrite the equation, letting f of x equal y. Then we switch x and y. The next step is solve for y. So we subtract 7 from both sides, and I end up with x minus 7 equals 1/3 x. Multiply both sides by 3, and we have y equals 3x minus 21. We are done. Rewrite the equation with the inverse notation. F inverse of x equals 3x minus 21. Look at example 5. Write the equation of the inverse. F of x equals x squared plus 6. First thing is to rewrite the equation. Y equals x squared plus 6. Then we switch x and y to x equals y squared plus 6 and solve for y. So we subtract 6 from both sides. We have y squared equals x minus 6. Take the square root of both sides, and I end up with y equals the square root of x minus 6. We are done. All we need to do is rewrite the equation in function notation. F inverse of x equals the square root of x minus 6. This concludes Flap 3 of Unit 10. Thank you.